What is function? Well, function is something that assigns value to other values, but in general, function is just relation between a and b, which for every x from a assigns exactly one I from b, and that x and I are in this relation. That is kind of mathematical definition of function, but let's look at more kind of user-friendly definition. Here I have function f that takes n, so all the natural numbers, and it returns us some r, so real number, and it is defined as I is equal to x plus 1, so I is kind of what this function returns, and x is what this function takes. So in general, you get this equation, f parentheses x is equal to y. So for example, f of 3 is equal to 4. Why? Well, you are using this equation to compute the returned value, and you want to compute I, and x is passed into this function. And since I call this function with 3, I will be equal to 3 plus 1, so 4. And if you call this function with 6, you will get 7. So notice that for every x you pass into this function, it returns us exactly one value. And now, if you look at definition, it says that for every x from A, there is exactly one I from B. And that's exactly what is happening in here. We are passing one x and we are getting exactly one I. So something like this cannot happen. We can't get 2i as a result of 1x. Also, we can get no I as a result of 1x. So, for example, if I have function g that takes some real number and returns us other real number, and it is defined as I equals 1 divided by x, this is not a function. Here, you can pause the video and try to figure out why. The problem is that there is not I for every x. So, for example, if I call this function with 2, I get 1/2, and that is okay. If I call it with minus 2, I get -1/2, and that is also fine. But when I call this function with 0, I get nothing. Why? Because you cannot divide by 0. And if we look at the definition, it says that for every x there must be exactly one I, and here is not, so this is not a function. Now, let's make even more user-friendly definition. Here I will define sets like this. So this is set A and this is set B. And in set A, we have some elements, let's say 1, 2, 3, 4, and 5. And in set B, we have other elements, like A, B, C, D. So now, if we have function from A to B, this function will kind of assign to every element from A some other element in B, right? So, for example, it can assign to A 1. But the important thing is that this function needs to assign some value to every element from A. So, for example, like this. Notice that there is exactly one arrow from every element from set A to some element from set B. So, that is correct. But if I have two arrows from some element in A to some other element in B, it is not a function, because in B is our I and in A is our x. So for one x we get two possible i's, and that can't happen. So this is not a function. And also every element has to point to some element in B. So if I get rid of this arrow, f is not a function, because it doesn't return I for every x. I think this is pretty clear, so let's look at some properties. function can be injective. And what that means? Well, there is no two arrows pointing to some element in B. There is always one arrow or none. So, for example, function f that is defined as I is equal to x squared is not injective. Why? Because, for example, 3 and minus 3 will both result into 9. So there are kind of two pointers pointing to 9. But, for example, function I is equal to x plus 2 is injective. Why? Because there are no two x's that will result into same I. So if I write this definition kind of mathematically, function a to b is injective when for every x1 and x2 from a, so if x1 is not equal to x2, the returned value is also not equal. So f of x1 is not equal to f of x2. I hope this makes sense. The other property is surjection, and what that means? Well, function from a to b is surjective if there is arrow to every element in B. So, for every I from B exists x from A and it is true that f of this x will result into I. So, for example, the function from a to b, where a contains 1, 2, and 3, and b contains a and b, is surjective. Why? Well, to every element in b leads an arrow. And it is okay that to b leads two arrows. The important thing is that there is at least one arrow to every element in b. But if, for example, 1 would be in relation with b instead of a, this function would not be surjective because there is no arrow that leads us to a. I think this makes sense. Also, function can be bijective. And what that means? Well, if function is bijective, it is injective and surjective. So, this is pretty easy. I hope this makes sense. If you have any questions, just ask and I will see you next time.